This is Chapter 6 Summary Notes on Nomenclature. This video will include ionic compounds, their properties, and how to write and name ionic compounds. All right, these will be binary ionic compounds, and we'll see some with polyatomic ions in the next video. Okay, so this picture that you see here on your screen looks at sodium and chlorine, sodium being on the left, in this gray silvery metal, and the chlorine gas is a greenish gas, but together they make salt, okay, that we use on our food. And here's the salt crystal in this picture right here, and then they show the crystalline arrangement of the sodium and chloride ions in this other image. All right, and it's interesting to see that the sodium ions, once they become an ion, they are much smaller than their neutral atom. The chloride ion becomes much larger, all right, because it gains that electron, which increases the volume of it, and the sodium ions kind of nestle in between the chloride ions in the salt crystal. All right, and you can take a look at that cubic nature if you open up a little packet of salt. All right, so let me back up a moment. The sodium chloride, it only takes one of each in order to make a unit of sodium chloride. All right, but now let's take a look at something that happens when you need more than one ion to balance the charge. All right, and this is going to be a very important part of writing formulas, is that you need to balance charge. All right, compounds are electrically neutral. The number of positive charges must equal the number of negative charges. So this picture does a nice job of showing that. Magnesium metal, all right, it's going to lose those 2 electrons that are in its outside shell because it has an S2 arrangement for its outermost energy level. Each chlorine has an S2p5, so it wants to gain 1 more electron in order to satisfy its octet rule. All right, so each magnesium electron will be contributed to 1 chloride ion to form the formula that you see here on the right, which is 1 magnesium and 2 chloride ions to make MgCl2. And you see the little formula here where it shows 1 magnesium at a positive 2 charge plus 2 chloride ions, each at a 1 negative charge, must equal 0. Okay, and of course negative 2 and positive 2 cancel each other out, and you get the neutral compound. Okay, so that's a little bit about how to get your formulas. All right, now let's try a couple of others. All right, sodium sulfide, and I'm going to just come down a little bit more to get some room here. Yeah, my number is going to be off of what you show on your sheet if you're using your PDF file for this video. All right, sodium, all right, Na. Let's get our sodium up here. And then sulfide. All right, the first thing you always want to do is write your ions. All right, so sodium is in group 1A. It's going to form a positive 1 ion. Sulfur is in group 6A or 16. It needs to gain 2 electrons to get to its S2p6 arrangement, so it's going to have 2 negative charges on it. Okay, and there's a couple of different ways you can do this. All right, we need to balance charges, so if we think about this little formula that we just used here, we have 1 sodium at a positive 1 plus 1 sulfide at a negative 2. And we need to equal 0. Well, in order for that to happen, I'm going to need 2 sodiums, not just 1. So my formula is going to be Na2S. But take a look at the charges on the formula and what happened over here. All right, there's something called swap and drop. So if you take the numerical value of the charge and swap them to become the subscripts behind the elements, you'll get your formula. All right, now there's one other way to take a look at this, how to write this formula. All right, and I call it the cartoons. Okay, so we have a a sodium ion that has a positive charge. We have a sulfide ion that has 2 negative charges. Okay? One positive can balance that negative, but I'm going to need to bring in another positive ion to balance this other one. So if you like this instead, it's a more visual way of seeing what's happening, just like in the pictures that you saw above. It takes 2 sodium ions, Na2, to 1 sulfide ion. All right, and that's your sodium sulfide. All right, now try to do this one here for the barium and chloride ions. All right, and again, pause the video and then come back and check your answer. All right, so if you take a look at your screen, you can see what I've done. I've shown you 3 different ways to take a look at this. We can do the swap and drop version, where we're taking the numerical value of the charge and creating them as subscripts behind the elements that are involved, and we get the BaCl2. All right, when that happens, we can note that we have 1 barium at a positive 2 charge. We now have 2 chlorines each at a negative 1 charge, and overall we have a 0 balance on the charge balance. All right, and remember the other thing is to take a look at the cartoons. Barium with its 2 positive charges because it's in group 2A. Chloride ion is in group 7A or 17 and needs 1 more on each ion to create its octet rule. And we circle the positive and negative charges because they're going to cancel. And again, we have 1 barium, but we have 2 chlorides to make the formula. Okay? All right, and then the very last thing to try is just picking out what the new compounds are for each of these. And again, pause the video and then come back and check your answers. All right, so if you're looking at the screen now, you'll see that 1 positive ion on sodium and 2 on oxygen, a negative 2 on oxygen, becomes Na2O. We need 2 sodiums to balance off the charge on 1 oxygen at a negative 2 charge. With aluminum and chloride ions, when we swap and drop those, or whichever way you choose to make your formulas, that's fine, just as long as you understand what's happening here. It doesn't matter if the answer is okay. The thought process is what counts. All right, so we have 3 plus charge on aluminum, negative charge on chloride ion, so we need 3 chlorides to balance that charge, so we get AlCl3. I think this one's the easiest one to see because of the various charges that are here. Magnesium 2 plus, nitrogen 3 negative. We swap and drop those, and again, it takes 2 magnesiums, each at a positive 2 charge. Ooh, that's not right. Okay, that's not right. All right, so that's a good thing to see. All right, so if magnesium has a plus 2 charge, we need 2 nitrogens to balance it. Okay, so let's double check that. All right, so we need 3 magnesiums, each at a plus 2, and we need 2 nitrogens, each at a negative 3. Now we have 0. All right, so that's not the right answer. All right, so I hope you didn't make that same mistake, because it's easy to do. Don't bring your charges straight down. They need to swap and drop. Okay, so remember swap and drop. It's a nice shortcut on working these formulas. All right, you can go back to do the little mathematical formula, or you can draw your pictures. One of those ought to work for you. All right, so good luck with writing your compounds.